All right, we have an object initially at rest and it travels a distance d in a time t. We want to know the time taken to travel 16d. So d is going to be 1 half at squared. Now let's figure out the time for, and let's get the time for this. When we isolate, we're going to get 2d over a under a square root is the time for the first one. Now let's compare that if we travel 16d. That's going to be 1 half at new. That's the new time squared. So we're going to get 32d divided by a under a square root, and that gives me t new. Now let's compare the two. So t new divided by t old is going to be square root of 32d over a divided by 2d over a. When we simplify this, this cancels, this cancels, this cancels, this cancels. We're going to get square root of 16, which is 4 times the original time. All right, now for the next one. When we accelerate, which of the following describes speed and acceleration as we reach terminal speed? So our speed increases, but our acceleration decreases because remember, our speed gets faster and faster, and then it levels off. The acceleration, though, starts off big, and then it just gets smaller and smaller and goes to 0. Uncertainty in the area. So let's be clear. The area is 5 squared, which is 25. We'll worry about sig figs in a second. Now the uncertainty in the area. So let's remember. So delta y equals delta a over a plus delta b over b when we deal with y equaling a times b. So let's apply that to the square. So we have the error in the area divided by the area is going to be delta length of one side plus delta length divided by length of the side. So we're going to end up getting delta A over 25 equals 0.2 over 5 plus 0.2 over 5, which ends up being delta A is 0.4 over 5 times 25. We simplify that, and that works out to 2 centimeters. So the choice on here that matches, 25 plus or minus 2 centimeters. We're going to skip this one. Air resistance matters, and we want to know what the acceleration as a function of time looks like. That's choice B. Fundamental unit. I don't know why this question keeps coming up. They always want amperes as the answer. It's just messed up. Now, when we deal with square roots and uncertainty, check this out. The way this is going to work is we have an uncertainty of 12% plus 20%, which is 32%. And this square root sign means you times it by a half, and that's how we're going to get 16% for our uncertainty. Okay, that's just the rule for square roots. I'm probably not going to put one like that on there, so I'm going to count this, but don't study it too hard for the exam. Now, object is dropped from rest from your surface, air resistance acts, and we know what acceleration as time is. Once again, they just keep repeating questions. Okay? All right. Uncertainty in the volume. So V is 4 pi r cubed over 3. Comparing this out. Uncertainty in the volume, that's going to be 2% plus 2% plus 2%, since we're going by percents, which is 6. How am I getting this? Because delta V over V equals delta R over R plus delta R over R plus delta R over R. Which is going to be 3 times delta R over R, but we know that this is just 2% since we're dealing in percentages, which is 6%. Here, I would not give you this question directly, so let's just not worry about that. Displacement versus time, if we've got negative acceleration, so let's be clear. We're moving on a straight line. Which graph shows motion with negative acceleration? This one here. We're moving forward and slowing down. So here, we wouldn't do this unless I gave you units, so we're not going to worry about that. And here again, acceleration versus speed. Our speed increases, our acceleration decreases, so choice A. They keep repeating questions, and they're not afraid to do that. Here, we want to know displacement versus time, again, using our graphs as a guide. So we're going to have this, and then we're going to continue forward and slow down. So that's going to be choice C. Again, pasting those graphs together that I give you in your study guide. I wouldn't give you this. Uncertainty in the volume. Again, so the volume is 8, because that's 2 cubed. Now let's compare. Delta V over V equals delta L over L plus delta L over L plus delta L over L, which is delta L over L times 3. So we have here delta V over 8 equals 3 delta L over L, which is going to be 3 times 0.2 divided by 2. So delta V is going to be 3 times 0.2 over 2 times 8. So that's going to be 12 times 0.2, which is 2.4. Choice D. I believe we've done this problem previously. Oh no, we've done a version of it. Look at this. Same, different thing. So acceleration versus time. We want to know if the speed of the particle is at 6 seconds. So again, we take the area. Keeping it in mind. So V is 1/2 base times height. When we actually do this, this is going to be 6 times 3 divided by 2, and that's going to be 9. All right, I'm going to actually finish up the kinematics questions in the next video.